Started here, the final session for the day on harmful algal blooms. Glad to see such a great turnout. I've been looking forward to this session. I'm Tammy Zimmerman. I'll be the chair for this session. I'm from the USGS. And our first speaker today is Dr. Campbell from Mercyhurst University.
It's nice to be here, and I'm glad there are so many people interested in harmful algae. It's something that I became interested in when I was doing my master's work in the Poconos and did some plankton work and saw some cyanobacteria blooms in some little recreational lakes in the Poconos. And that may have been at some level what triggered me to want to take a sort of a regional look at the cyanobacteria blooms in our area here this summer. I've got several things that I would point to as what led me to do this project. Dr. Diz and I have been working with our students at Gannon and Mercyhurst respectively for the last 2 years with a grant through Pennsylvania Sea Grant and NOAA to develop a model of the cyanobacteria bloom phenomena in Presque Bay, and Dr. Diz will be speaking more about that. But Angelea, who is one of my co-authors pictured here, on the Environaut, Gannon's boat that we've been sampling from, this summer kind of took a big step and was doing pretty much all of the sample analysis. After having learned how to do phytoplankton analysis last summer, she did the zooplankton this summer too. So that gave me a little bit more time to play since she was able to handle the processing of the samples. And it was intriguing as the summer unfolded. There seemed to be a lot of press all around the country about harmful algal blooms, not just in the Great Lakes, but in places as far away as California and Maine and Minnesota. And the news report in mid-July indicated that we were expecting the bloom in Lake algae to be pretty big, maybe not as big as it had been back in 2014, but a big one. The other thing that inspired me to do this particular thing were the weekly emails I was getting from Amber Stillwell reporting on our microcystin toxin levels and other toxins that she was measuring here. And even though I never replied to any of those emails, I did look at some of them. And this particular one caught my eye because I didn't realize that they were sampling places besides the waters of Lake Erie and Presque. When I saw Eaton, I thought, hey, you know, that's an interesting lake and it's not too far away, and you know, I've got a couple of hours this afternoon. Maybe I'll go out and grab a plankton sample. And it helped that my son, who's a John too, has a little bit of history with plankton sampling, and he's the one that actually suggested that maybe we go out to some of the lakes and get some plankton samples that we could compare in late July, what we were seeing in all the lakes in the region compared to Presque Bay. So on July 27th, we started with Eaton Reservoir and then Findlay Lake, since it was right down the road. And I lied to John. I told him that Lake Pleasant was on the way home. And as the crow flies, it wouldn't have been too far, but it's not actually too easy to get from Findlay Lake to Lake Pleasant, as I found out. But we sampled Lake Pleasant, and then over the next week, we found time to visit as many of the lakes that we could. We wanted to kind of hit most of the natural glacier lakes in the area, as well as some of the larger reservoirs. And my son is teaching me about technology. He created a website that we could use for posting our results. And if any of you are interested, we've got a website called harmfulalgae.com where you can go to get all of our results. And you'll just see sort of the tip of the iceberg today with this presentation. So we sampled all the lakes once initially within the 8-day period. And Lake Pleasant and Canadota, we decided to sample again because the densities of cyanobacteria we found in late July were so low, we just wondered if maybe it was an unrepresentative sample. So we sampled those two lakes again. We sampled from publicly accessible locations. If there was a dock or a boat launch area that allowed us to get out into deeper water from shore, we took most of our samples from piers and docks. And we used a 65 micron mesh Wisconsin-style plankton net and a 5-meter long horizontal tow. I would have liked to have done oblique tows or vertical tows, but since typically the water wasn't much deeper than a meter or two, it made more sense to go with horizontal tows. For Chautauqua Lake, which we went to last, we decided, since it was so big, that we took two samples, two different sites, one at Long Point, where there had been a report of high microcystin levels in late July, and then we went down to Jamestown and took a sample at another park northwest of Jamestown. Presque Bay, we didn't do extra sampling there since we had already been going out on the bay every 2 weeks with Dr. Diz and the Gannon students to do our regular sampling as part of the NOAA Pennsylvania Sea Grant funded study. But the data that I used here were the data for 2016 and 2017 in the same window of time in late July as the samples that we collected from the other lakes. And we have got 3 sampling stations there. I'm sure Rick will give you a little bit more information about the particulars of this study, and Angelea will also be sharing some of her findings with the phytoplankton and zooplankton. Our laboratory processing was pretty standard. We'd look at the samples live and take pictures, and my son got into doing the microphotography of the algae, and most of these pictures are his. And after looking at the samples live, we preserved them in 5% buffered formalin, and then took a 1 milliliter subsample to count at 100 times magnification in a Sedgwick rafter counting chamber, and then calculated the population densities in original lake water in units of numbers per liter. The data provided some interesting snapshots of the different types of variations in plankton numbers among and within lakes. The Lake Erie Presque Bay data here kind of shows July 27, 2016 results compared to this summer's results. And interestingly, the total densities were lower in late July this year than they were last year. But Microcystis, which is the taxon that has been often associated with the production of the microcystin toxin, had almost double the densities this year. But in general, we had a much more vigorous bloom of other cyanobacteria species last year at the end of July than we saw this year. The samples from Chautauqua Lake were particularly instructive because it gave us an idea of how much sample population densities of cyanobacteria might vary between 2 different sites on the same lake on the same day, with several orders of magnitude difference in the densities at Long Point compared to the site near Jamestown. And most of those big differences were due to one genus, Aphanizomenon. The Chautauqua Lake site was interesting too because these large spherical colonies of trichomes and gliotrichia were visible to the naked eye. And I had no idea because I had not seen very many of these before in a plankton sample. So we were kind of excited to see what those balls were when we saw them in the lake. To give you an idea of the regional variation in 2 of the taxa that seem to be most widespread among the lakes, this graph shows in orange bars the Microcystis densities and in blue bars the Anabina species. of which there were several different ones. And notice it's a log scale, so it doesn't really give you as accurate a picture of how much things varied among sites. But I believe these two taxa are ones that are commonly associated with some of the types of toxins that Amber ended up measuring, and I'm sure we'll learn more about that from her. So the Anabina was definitely the genus of cyanobacteria that seemed to be most widespread in our regional lakes, and there were a handful of lakes that had very low or non-detectable levels of microcystis. When you take the microcystis data and take out the log scale, you can get a better appreciation of the actual differences in densities among the sites to compare them. And I singled out microcystis because of its relationship with the microcystin toxin production. And sure enough, Presque Bay topped the chart for all the sites that I measured during this narrow window. And I'll be curious to see with the difference between last year and this year in microcystis, if Amber has any data on how her microcystin levels compared this year to last year too in the bay. Aphanizomenon is a good example of why you need to look at samples live. The photograph on the top is aphanizomenon in a live sample where the trichomes are often in a bundle of sticks which zigzag back and forth against one another. And then when you preserve a sample in formalin, it usually breaks up those bundles of trichomes, and then you find the individual trichomes as in the diagram at the bottom. And this particular cyanobacteria is the one that seems to be most capable of generating really high population densities in the lakes. And interestingly, Findlay Lake, which was one of the lakes that seemed to have the largest densities of cyanobacteria, has still got a large bloom of aphanizomenon as of last week. So unlike the bay, where the cyanobacteria blooms seem to dissipate by September, we've still got a booming bloom out on Findlay Lake. When we resampled Canadota Lake, it was interesting to see how much the cyanobacteria population densities changed in just 2 weeks, with the Anabina taxa in particular blooming during that period. And a similar thing, only even more dramatic in Lake Pleasant between late July and 2 weeks later in August, with an aphanizomenon bloom that really took off, but also the Anabina again. Microcystis, fairly low densities in Lake Pleasant and not as much of a dramatic increase. So what I conclude here is nothing all that remarkable. There's no surprises here in what I'm saying, but the cyanobacteria bloom formation in our lakes in this part of the country is apparently a seasonal, regional phenomenon that is understandable on the basis of how these things respond to temperature changes on a seasonal basis and light availability. But it was kind of interesting to me that the same taxa were showing up in all of the lakes at about the same time, even the lakes like Lake Pleasant and Canadota that have better management and control of their nutrient inputs. There are large variations in the cyanobacteria population densities within large systems from year to year, as in Presque Bay, and from one site to another on the same date, which we could see from the Chautauqua Lake data. And we've got so much data now on site-to-site variation in Presque Bay, we could provide lots more examples about how variable within the bay the plankton numbers are. And finally, because of what I saw in Canadota Lake and in Lake Pleasant, I think it's important to mention that any kind of ranking of regional lakes based upon single date sampling is probably not very reliable, especially now that I see Findlay Lake still blooming in late October and early November, it's possible that some of these other small lakes might have pretty dramatic blooms later in the season than what we see in Lake Erie and in Presque Bay. So I want to give special thanks to Rick Diz, who, now that he is retired, is now an apple cider engineer, and he's teaching me his craft. And we're going to have a taste testing episode soon where we see who made the best tasting hard cider with his apples. And Sean Rafferty and Pennsylvania Sea Grant, I thank Sean Rafferty and God that our funding through NOAA actually came through again this year, despite doubts about federal budget. And Rick, that's your grandson.
Yes, I recognize.
What's his name?
Graham.
Graham. I always enjoy our trips out on the Environaut, and I wish in some ways that I worked at Gannon University for that reason, but I'm okay with Mercyhurst. I've been there 34 years now, so I guess I'll hang out with them yet. So if you have any questions, I'd be happy to answer them. Yes.
I can tell you at Chautauqua, the phenomenon is still going 2 weeks ago.
Is it?
Yeah.
Wow.
This is the North Basin, but on the other side, on the eastern bank of the western bank, more on the north end.
Yeah.
It was the chunkiest I've ever seen any of the phenomenon blooms ever. It was intense. But it's really great to see that diversity across all the different lakes. Did you compare any of the counts to the water quality parameters or environmental?
I did not. This was purely biological. You know, it's nice to kind of work without the constraint of a grant. You can do whatever you want. Whatever you don't want to do, you don't have to do. Yeah.
Could you give us an idea of how these numbers and these lakes compare to Western Basin Lake Erie? I mean, like how much? Threefold?
You know, I would imagine that some of the higher densities that I've reported here are probably comparable to what they're seeing in the Western Basin. And I have not made direct comparisons, but some of the aerial photography, satellite imagery of the bay, you know, compared to the Western Basin, it's got a similar look. So, I mean, the bay in a way is like a little mini version of the Western Basin because it's shallow and it's more directly affected by the nutrient inputs that are coming into it. So, but I honestly don't know. I haven't looked at the population densities in the Western Basin to compare. That would be an interesting thing to do, yeah.
So there's no water quality or nutrient data with this thing?
No, there is not. I have a lot of information about the lakes, though, and there's some nice, straightforward explanations as to why Canadota Lake is so clean and Findlay Lake is so not clean. And it has to do with all those cottages that are connected to a sewer system at Canadota Lake and not connected to a sewer system at Findlay Lake. So septic tank leachate, I'm sure, is one of the big factors contributing to the strong bloom every year at Findlay Lake. Until they can do something about the septic systems, they'll probably see it or it'll get worse.
We have time for maybe one more question.
I do have one from the stream, actually. Can you speak more to the temporal variability you saw? Was it on the scale of hours or days?
The temporal variability in Canadota Lake and Lake Pleasant was 2 weeks difference, which I tried to look at weather data to see if there might have been something to account for that. If we had really warm weather in those 2 weeks, and it wasn't. It was actually unseasonably cool. There were a couple rain events, so it could have been, you know, a little input of nutrients that caused the surge. But even that, I mean, one of the storms was a ½ an inch of rain, and the other one was a 1/20th of an inch. You know, so it wasn't enough rain to really account for a big surge of nutrients.
Thank you, Dr. Campbell.